Hi Bobcats! In this video we're going to take a look at how we write formulas for and names for covalent or molecular compounds. These are the compounds composed of a nonmetal plus another nonmetal. Our objectives are to go both ways, take the name and write a formula, or take a formula and write a name for covalent compounds. The nomenclature of covalent compounds is a bit more straightforward than the ionic compounds. When these compounds are formed, their electrons are shared, not transferred, so that means we have no charges to try to balance. So we have to kind of do something else to indicate how many atoms of each element are present, since the charges won't be available to do the crisscross process. So take a look at this list. You might want to pause the video and look for whatever patterns you can find. Just looking through this list, I'm seeing things like phosphorus pentachloride, dinitrogen tetroxide, tetraphosphorus decoxide. So it looks to me like some of this is very, very similar to our ionic nomenclature. We have the first element named first, the second element named second. The second element has the IDE ending going all the way down. But something's really different here. We're seeing these prefixes that say things like di and mono, penta, tri. And you might notice that those are correlated to subscripts. One other thing I want to point out, mono is used for one, but when the first element only has one, we don't write it. So for the very first compound listed here, N2O, we say dinitrogen monoxide, so the mono slips in there for the second element. But if you jump down to something like CO2, which is carbon dioxide, we definitely use the di, but where we might put a mono, it's missing. So mono is not used on the first element, but these numerical prefixes are used all the time on the second element, and they're only used on the first element when they're not one. This table shows a list of the first 10 numerical prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. The ones that tend to cause students a little bit of trouble, tetra for 4, because that's not a real common prefix for 4. You might have seen the word tetrahedron at some point in a math class, but it's not really commonly used for 4. Hepta for 7. People want to change that first letter to an S, so make sure you keep it at an H. And then nona is just kind of weird, and again, not one that's real common. Most of these others you see a lot, like deca for a decade, octa for an octagon, like a stop sign, and then the smaller numbers appear much more often. Okay, so what are we going to do for formal rules? We're going to write the first element name. Then we're going to write the second element with the IDE ending, and then we're going to put numerical prefixes in front of both elements to show how many are indicated by the subscript. And then we're going to skip mono on the second element. If it's on the first, I'm sorry, I just said that backwards. We're going to skip mono on the first element. And if there's only one of the second element, we definitely write mono, like carbon monoxide. Also, if the second element begins with a vowel, we tend to drop the vowel at the end of the prefix. So for instance, when we have one carbon and one oxygen, we call it carbon monoxide instead of carbon monoxide. That's not something that I'm going to test you on. If you wrote carbon monoxide on a test, I'd give you full credit for that. Let's work a couple of examples. N2O5, well, the first element is nitrogen, and we need to put a numerical prefix in front. The number is 2, so we'll call it dinitrogen. First element goes by its normal name. And then the second element is oxygen. We're going to change that to have an IDE ending, so it'll be oxide. And we're going to add a numerical prefix for 5. So we'll put pentoxide at the beginning. And again, if you wrote pentaoxide, I'd give you full credit for that. The second example here says tetraphosphorus decoxide. So when we go from the names to the formulas, the numerical prefixes tell us what subscripts to write. So phosphorus is the name of the first element, and that numerical prefix tetra tells me to write a 4. Oxide means the second element is oxygen, O, and the dec prefix tells me I need to write a 10. Take a moment and see if you can decide which one of these pairs of name and formula is wrong. One of them is wrong and the other 3 are correct. So pause this video and see if you can decide which one is wrong. Okay, hopefully you came up with an answer of C. Why is this wrong? This is wrong because magnesium and fluorine are a metal plus a nonmetal, which means that it's an ionic compound, and we do not use numerical prefixes with ionic compounds. You always have to make sure that the first step is deciding what kind of compound it is, so you use the right rules. The names that we looked at on the previous slide, or a couple of slides, are the IUPAC names for compounds. There are actually 2 substances whose common names were so widely used that IUPAC finally decided, you know what, we're just going to make their common names their official names. The first of these 2 compounds is water, and the second of these 2 compounds is ammonia. So the official name for NH3 is ammonia, not nitrogen trihydride. And the official name for H2O is water, not dihydrogen monoxide. There is a chemical known as DHMO that has quite a reputation and quite a history. So if you would take a moment and look at one of these sites, let's see, I think the very first one is a public service announcement about DHMO, and the other sites are just some sites that provide information about this chemical. So go ahead and take a moment, pause this video, and check out these sites, and then come back and we'll talk about it. All right, so hopefully you took a look at that and you discovered that DHMO stands for dihydrogen monoxide, dihydrogen H2 monoxide O. I'm always amused by these sites because you can take any substance and make it sound really, really scary. And that's a lot of what they're trying to illustrate with these DHMO sites. I think probably, things that you think of as being really just completely harmless. If you look into it deeply enough, you can find something about them that looks scary. So it's always really important when you're looking at the hazards of a chemical to keep some perspective. Our objectives were to write names and formulas for covalent compounds.